Alright, you guys, hi. This is video 932, and it is our second video for the standard on solving different radical and nth-root equations. And it's also our last video for the chapter. This video is going to go through a couple examples that are going to seem very different from each other, and the hardest part I would say is making the decision of what method you're going to use to solve it. The actual solving, once you decide on that method, you'll find very simple. I feel that this is one of those where I can't give you a fix for everything. You're going to have to make a decision every time a new problem is put in front of you as to what strategy to use. So just like factoring, when you have a factoring problem in front of you, you have to decide, is grouping the best way? Is GCF the best way? Is it the difference of perfect squares? What way can I factor this? Well, the same thing's going to apply to these different solving ones. You're going to have to make a decision as to what method is the best method to proceed with. So if you can get past that and make that correct decision, then you're going to find the solving in these not so bad. So let's go ahead and get started, and we'll go through each of them. So here's our first one, and the method we're going to be using is U substitution. So for this one, I'm going to decide what I want my well, the reason we're using U substitution is because I don't have a quadratic. I've got a fourth degree polynomial, but I want to be able to solve it. I'm not going to substitute it into my calculator, and I'm going to have to find another strategy to do this. And so one of those strategies is going to be to substitute in, and I always choose the one in the middle, because in a typical equation, ax squared plus bx plus c, the variable is x, and this is the spot where that variable of x is found. So in this case, I want my u to be x squared, because in this position is an x squared. So I'm going to replace this x squared with a u. Now, nothing happens to the 3. And you say, well, what happens to the x to the fourth? Well, u squared is x to the fourth, because if you square u, you get x to the fourth. So now what I've done is I've turned this fourth power into a quadratic, in which I know how to work with quadratics. So I'm going to use the box to factor this, and I'm going to multiply. So I've got 4u squared and a 3, and that gives me 12u squared. And I'm going to use a negative 6u and a negative 2u. So those are going to go in my box so that I can factor. And remember, whenever these two boxes are negative, that's when we pull a negative out. So in this case, it's a 2u across. Up is going to be a 2u. Vertically is a negative 1, and horizontally here is a negative 3. So that means that I have 2u minus 1, and I have 2u minus 3 equal to 0. So what I do next is I use a zero product property. So let me go through the steps again. I want you to write them down. The first thing you do is the u substitution. So you decide what u is going to equal, and that will come from this position. Okay, because that's like where your single variable would have been. The second thing you do is you factor the quadratic, because now you're left with a quadratic. The third thing you're going to do is the zero product property. So that is that I have 2u minus 1 equals 0 and 2u minus 3 equals 0. So if I add 1 and I divide by 2, I get a half. And over here, if I add 3 and divide by 2, so I get u equals 3 halves. Well, here's the deal. We weren't solving for u, we were solving for x. So now your fourth step is to set it back equal to the x's. And that is that if u equals x squared, then x squared equals 1 half, and x squared equals 3 halves. So your last step would be to take the square root of both sides of both of these. So I'm going to take the square root of this, and I'm going to have x equals plus or minus the square root of 1 over the square root of 2. We'll come back to that in a second. And here, taking the square root of both sides leaves me with x equals plus or minus the square root of 3 over the square root of 2. But we've already learned about how to rationalize these, so these are not my final answers. So step 5 would be to rationalize if needed, and we do. So to rationalize these, I'm going to multiply by root 2 over root 2, and I get plus or minus the square root of 2 over positive 2, and here you get plus or minus the square root of 6 over 2. So these are your solutions for x, and there are 4 of them because you have plus or minus on both sets. Okay, we're going to try that again, so don't worry, we're going to get another one. Okay, this one, however, is a different strategy. We're going to be raising both sides to the same power. Well, the power that I want to raise them to is actually to get rid of the denominator. So I'm going to raise these both to the 5th power because that is going to eliminate the fraction part of this, leaving behind x minus 3 quantity squared equals just a 4x. Well, I can expand x minus 3, so that would be x squared minus 6x plus 9. Remember, I am actually squaring x minus 3, so that means x minus 3 times x minus 3 equals 4x. X squared minus 10x plus 9 equals 0, and now I'm going to use the zero product property after I factor. So I have x minus 9 and x minus 1 equals 0, so x equals positive 9 and x equals positive 1. Would be a good idea to go back and check your work, and we talked about that in our last video. Alright, our third example is another u substitution, but this time I'm substituting not just an x, but I'm using this quantity of x plus 1. So here's the key. The coefficient on this is a 1. The coefficient on this is a 1, like as in on the outside of the parentheses. Okay, so if I want to put this in the form of u squared minus u minus 2, then what does u represent? Well, u must represent the quantity of x plus 1 to the 1/3 power, and I know that because in this position is x plus 1 to the 1/3 power. This is the u, that's my u, where does it get replaced? Now it's not negative because I'm using the negative for this. So now that I have u squared minus u minus 2 equals 0, I can very simply factor that to u minus 2 and u plus 1, leaving me u equals positive 2 and u equals negative 1. But remember, we weren't solving for u. We were solving for x. So at this point, I'm going to set the 2 and the negative 1 equal to this quantity of x plus 1 to the 1/3 power. So here's the last set of steps, or last part of this process, I guess. So x plus 1 to the 1/3 power now equals 2. And x plus 1 to the 1/3 power equals negative 1. Okay, and I'm going to use a strategy at this point that we talked about in the first video, which was to eliminate the radical, or the power here. So I'm going to cube both sides. I'm actually going to change color so you can see that step too. So I'm cubing both sides. Oh, that's terrible. So I have x plus 1 equals 8, so x equals 7. On this side, when I cube both sides, okay, I get x plus 1 equals negative 1, so x equals negative 2. And these are my two solutions. I'm going to share with you now what I know students will try to do if they don't watch this video. So when you see your friend who has not watched this and has not paid attention, the first thing they're going to want to do is just cube each part of this. Like literally throw a big cube on here and say, well, I'll just cube it and I get rid of everything. That does not work, because when you cube this, you're actually multiplying x plus 1 to the 2/3 power minus x plus 1 to the 1/3 power minus 2 times x plus 1 to the 2/3 power minus x plus 1 to the 1/3 power minus 2. You'd be multiplying these two things together. That doesn't solve our issue. So it is an incorrect strategy to just cube stuff. Okay, that does not work. You must use this method. All right, we got one more example together. All right, for this one, it's a simple u substitution, but this time what my u is going to equal is x to the negative 1. Okay, x to the negative 1 power. So it's simple that I'm going to still replace this and make that 6x squared plus a u, or 6u squared plus u minus 2, because I got to bring that over. And I will proceed I prefer to use this method, so 6u squared and minus 2 makes negative 12u squared. And I think 4u and negative 3u work. And because this one is negative, I will pull out a negative 1, 2u, 3u, and 2. So that leaves me with 3u plus 2 and 2u minus 1. But I wasn't solving for u. I do need to finish solving here, so I get 3u plus 2 equals 0, 2u minus 1 equals 0, u equals negative 2/3, u equals 1/2. All right, so using that, I now will set it back equal to this x to the negative first power. So I'm going to change colors so you can see where this step comes in, and that is x to the negative 1 equals negative 2/3, and x to the negative 1 equals 1/2. All right, well, what is this x to the negative 1 business? Well, what it means is that I want to take the reciprocal. So my x actually equals negative 3/2, and x equals positive 2. Okay, so those are my two solutions for this one. All right, you guys, great job, and we'll keep working on these. The u substitution's just new, and again, you're going to have to find a strategy that's going to work for you, and we'll practice those together.